lecture, I'm going to be covering about the class compositions. So what I'll have is I'll have a couple of classes. Actually, before that, let me just go ahead. One is the a person class. The other one is a car class, and then there is a driver. So let me show you what the person is all about. The person class is the same one as we did in the previous one. The only thing I have in here now it's copied in Iris. Come on, open up. So and it's separated in .h and .cpp file. So in this file, as you can see, class person has private members and public. So as I mentioned before, there is private, public, and protected members. Private are those that can be only seen by the class and nobody else. Public are those methods that can be seen by everyone outside of the class. Okay, uh, you know, under public you can have methods or data members. In this case, there's two data members, which is private, the first name and the last name. And then under public, I have the mutators and accessors. String get first name, void set first name, string get last name, and then set last name. Okay, the getters and setters. Um, and the implementation of this is in CPP file. So let me go ahead and show you that. Uh, escape vi that person that's cpp open up edit um, and in here you'll notice I include person.h, which is the header file, and the way you go about writing um, the member functions is by this syntax. So you have, and make sure you include the .h file. So in here I have string, which is a return type, and then this is the special way to denote the class. Okay, I give the name of the class, colon, colon, and then the name of the method. Then I go ahead and give its implementation. In this case, I've only given it for get first name. Obviously, you need for get all the accessors and mutators, right? Get first name, set first name, get last name, and set last name. But just for the sake of simplicity, I've only shown you one. Um, and so now you have a person class. Let me show you another class now. Yeah, which is a so here I'm directly going into the .h file. So a car is in it's a car, right? It's a vehicle. And notice in here in this file, so I have the definition of class car, but I do include person.h in here because I intend to use another class in this class car. And in this case, I'm calling it, there's a person, that's the owner, and that's a private data member. And the public accesses and mutators are person get owner, and then the set owner. Um, Now both of these methods are inline methods for this class. One thing to keep in mind is an inline method doesn't really mean that if you say it's inline that it fits in one line, but rather it means that its implementation is in the .h file itself. In this case, I have it, so I don't need a .cpp. Okay, so I hope you understand the concept of car and and the person. Now, the other thing you need is a driver, right? You need a main class that's going to deal with both of these. Let me go ahead and exit out of here. I have a driver class, driver.cpp. Come on, open up, edit. So in here, I only include car.h because car.h has person in it as well. Um, so in this, I say car BMW. I need a car, and then I say person BMW owner. Now, one thing if you recall is both of these classes did not have a constructor. So if you recall, what happens is if you do not specify a constructor, the compiler will give one to you. Now this class is simple that all that has is a car and a person. You can build on top of it. Uh, you can call the accessors and mutators and do all kinds of fun stuff with it. But for the sake of simplicity and showing the example of class composition, I chose this. Now here, go ahead and run this. Once again, I compile only car.h and driver.cpp because car.h knows about person and driver is the main class. Okay? No errors, no warnings, nothing. I mean, you're not going to see an input because you're not going to see an output because there is no cout statement, but that's how you go about uh, including one class into another. Uh, and and using mutators and accessors and this. So the key concept here is if you know about the .h and the .cpp file, um, you can include other classes in your class. And this could go on, a class can have a class within a class within a class, etc. I mean, I don't know how much further you want to take this, but this is the most simple example. Um, okay, so hope that's clear. Okay, next up is vectors. Now, what you might want to do is read up on Chapter 7. Chapter 7 does mention about arrays. Um, because in talking about vectors, I do compare them to arrays, so it's good to know. But if you haven't read it, hopefully you've read it by now. But arrays, think of it as like holding blocks for some sort of a data type. Vectors are similar to arrays. They can store the same type of data in its compartments or cells, except that vectors they can grow dynamically, whereas the size of the array has to be adjusted if you want to grow it. Ve Vectors are part of the standard template library, so the way you'd go about working with them and use include vector. Okay, and vectors, yet again, a very important concept. I cannot even think of the number of times I've used the vector class. I've used it so many times, numerous times. In my career, in this class, and in the future class of programming, used over and over again. So very useful, dynamically growing compartments or blocks. So the way you initialize the array, these are the three ways. One is, well, first of all, before you initialize it, the way you go about using array is vector and the name of the vector. And in these type of brackets, you put in the type, integer, whatever. And instead of the integer, it could also be a class, right? So the person class that we were studying earlier, or the car class, whatever, right? Could be a class, existing data type, whatever. And the way you initialize it, equals to, open parentheses, close parentheses, and then you put in the number of values. That's one way, or you can do it without the equal sign. Oops. Or this is the third way of going using the vector class. Now what I'm going to do is I'm going to be covering the following operations of the vector via examples. The first one is iterating through the elements in the vector. Um, is this right here? Okay. Include IOStream, include vector, initialize the vector. I just chose to initialize it this way. It doesn't have to be this way. And then uh, int, that's the vector type, and then iterator. Okay, the keyword iterator and then the name of the iterator. And as the word implies, it lets you move from one point to another in the array or iterate through it. So this is the iterator. You initialize it to num with dot begin. Begin gives you the um, first element. Num end is the end of the vector. Plus plus iterator, you increment the iterator by one. And then let me go ahead and run it. I ran it already. You probably saw the output. 1, 2, 3, 4, 5. Okay, so that's how you go about iterating through the array. Next one is adding an element to the vector. Is this, I think this is just initialization and not displaying it. Adding is right here. So these are, while I'm on it, let me show you. So these are the different ways that I've initialized the array that I showed you in the example. And then I output each one of the vector 1, 2, and 3. Now, the iterator method that I showed you to output the elements in the array, that's my preferred way. It doesn't have to be the way. This is another way. This is the syntax. You can look at it, copy it if you want. Um, but nonetheless, I've got three vectors in here, and then I output each one of the vector. And when I run it, okay, you see the output of vector 1, 2, and 3, etc. Next up is adding elements to the vector. So here I've got the vector um, 1, 2, 3, 4, 5, and that's the initial vector, and I output whatever the contents are. And the way you go about adding elements um, to the vector is by using the pushback method. So the name of the vector dot pushback, and then in parentheses um, you give it the integer. You have to give it the same type. That you gotta be careful of that, right? So let's say, for example, if I tried this, and I tried to run it, it's gonna give me, look, you're trying to put in a character, and it's an integer array. So you gotta enter the same type of data type in the vector that you initially initialized it to. So in this case, I've got a vector of 5 elements, 1, 2, 3, 4, 5, and then I'm num.pushback 6, num.pushback 7. And then I output the contents of the vector. So what do you think is going to happen? Push back, what it does is it pushes um, at the end, towards the end. So it starts incrementing here. So not incrementing by adding elements here. So after 5 is going to be 6 and then 7. And once I walk you through these examples, I'll tell you some other um, functions of the vector class that you can use. Next up is accessing elements in the vector. You can access the element via the iterator, right? Because we talked about it. Um, you can iterate from one element to the other. Um, what you can even do is I can update this example. Uh, what I can do here is while I've accessed a particular member, I can um, I can update the contents right here. So as you're iterating through, you're able to access the elements in the array. And I wanted to cover iterating first because that's probably the most important part because once you can iterate through the array from the beginning till the end, you can access it, you can add elements to it, you can delete elements to it. Oh, delete. Yep, I think I had an example of delete. Yep. Okay, so the way there is a method called popback that removes the last element. So in this case, it's going to be 7. So you got a vector here of prime numbers 2, 3, 5, and 7. And this is the initial vector. I output all of of its content. Then I say pop back. So you pop from the back from the end, and then I output the vector. So what happens is this was the initial vector. This is after you've popped the last one. And you can continue to do so. So if you were to do this again, 5 would be deleted. You do it again, 3 is going to be deleted. You do it again, 2 is going to be deleted. And and the interesting part is since it's dynamically, the size grows, so you don't, you're deleting, and if you want to add, if you start adding back elements into it more than the initial size, you don't have to worry about resizing it. It does it for you automatically. So these are some of the methods in the vector class. Size, it returns the number of elements present in the vector. Clears, it it's going to remove all the elements. So let's say, for example, you had a vector you want instead of trying to delete one element at a time, pop back, pop back, pop back, all the way till the very first element. You need to say clear. Front, use the first element. Back gives you the last element in the vector. Empty returns true if the vector is empty. Capacity checks the overall size of the vector. There are some more methods, specifically related to iterators, but I don't want to cover each and every one of them. These are some of the important ones. Well, actually, talking about it, maybe I should because as you're using the iterators, it comes in handy. So these are some of the iterator related methods. Begin, pointing to it gives you the first element, and um, here's a tricky thing about end. End does not give you the last element in the vector. Instead, it gives you a point after one. So if your last element is number 7, it's going to give you the point after number 7. So if you're looking at the very end element, you want to do n minus 1. Our begin returns a reverse iterator pointing to the last element in the vector. Our end returns a reverse iterator pointing to the theoretical element preceding the first element, right? So it doesn't give you the first one from the other side, but it's the one before it. So with these end iterator, what you want to do is if you actually want the element, um, you need to subtract from it or add to it depending on um, where you are. Um, Cn, I did mention. Cr begin returns a constant reverse iterator pointing to the last element. Cr end returns a constant reverse iterator pointing to the theoretical element preceding the first element, right? So anytime you see an end, right, it's a reverse Rn, or is it a regular end or a constant end? It's always one element off. Since we're doing pretty good on time, I wanted to cover file operations. Now, what this is, so far, we've covered, reading and writing, etc., from the user's input, from the console, etc. There's going to be time when you'll have to open up a new file, read its content, or read the contents from the user, open up a file, and write to it. So you're going to come across these instances where you're going to have to deal with inputting and outputting into a files, reading, writing, etc. I mean, all the operations that you did with the user, you have to do that with the file. So the way we go about doing this, once again, C++ provides a library which is called fstream, file stream. and the way you go about using it. Pound include fstream. And there are three types of stream, okay? One is OF stream. This is the output file stream and is used to create files and write information to the file. Next one is if stream. This is used for input file and is used to read information. Now, one's read, one's write. What if you want to do both? For that, you want to go ahead and use fstream. You also want to use fstream in situations when you're not sure if you're going to be reading from a file or writing to a file. Me, what I typically do is I tend to use fstream most of the time. This way, I ensure to myself that if I need to write to it or read from it, I can do it anytime. These are some of the modes, the flag and description. Um, if you have the mode, if the mode is APP, it's you know it's open in the append mode, so you're able to append to it. If you open the file and you have ATE, open the file for output and move the read-write control to the end of the file. Because a lot of the times, or sometimes what you might have to do is you might have to place the cursor or towards the end of the file. This is one of the operations that's available for it. If you're going to open up a file for reading, it's in. Writing, it's out. If the file already exists, its contents can be truncated. I mean, you can disregard all the contents by opening it in truncate mode. Okay. Some more functions for file. And don't worry, you're going to see an example where I cover several functions, so you'll get to see input and output to a file, opening it, etc. But this is just a general overview of the functions for the file. Close method is used to close a file. When you open the file, read, write, do whatever operations that you ought to be doing, at the end, you're typically going to close the file. If stream, like iStream, keeps an internal position with the location of the element to be read in the next input operation. Um, Offstream, like OStream, keeps an internal put position with the location where the next element has to be written. So you have, what I refer to it as a cursor sometimes. There's an internal position in the file that when you read and write from it, it's at a certain position. So based on that position, it's going to read from it or write from it. Um, Finally, the FS stream keeps both the get and the put position, like IO stream. Sorry, I've been having troubles with my throat. It's been a couple of weeks now, but still kind of dealing with it. Um, so FS stream keeps both, um, the next element that needs to be read in, or the next element, or the position where you're going to write to. Once again, if you're not sure, you're going to use FS stream. F stream, not FS stream. I typically use F stream most of the time, um, for the same reason that I use F stream when I'm dealing with the file. And the seek G has an offset and a position. Seek P has an offset and a direction. You're going to use these functions to move the cursor back and forth within the file because you're going to run into situations where it won't be the case that you're going to have to start reading from the first element or writing from the first element. Might be in the middle of the file, the end of the file, or someplace else. So these functions can come in handy. Some more BEG offset counted from the beginning of the stream, um, cur offset counted from the current position, and offset counted from the end of the stream. Okay. Let me go ahead and show you an example. And I'm gonna go through it line by line so it's kind of clear. Um, Include fstream, okay, that's the file, and then I have a character array of 100 characters called data. And in this example, I'm using offstream. because I'm going to be opening a file in write mode. So I've called the file uh, out file, and I say out file.open. That takes in the name of the file. So it's going to open a file called a file.dat. I'm going to say writing to a file, enter your name. I'm going to take the input from the user. And as we get, as we get further along, I think we're kind of um, out of time here from a semester perspective, but what I wish I could have done is show you more examples where not only are you just opening a file for reading it, but you've got multiple files that you're reading from. You're reading from one file and then writing to the other. But in this case, you're taking the input from the user and you store that into the array, character array called data. And then what you do is you write the data to the out file. Okay, this a file.dat, this is where you write the inputted data. So the way the syntax is the name of the file, data, and del. Okay, kind of like cout, right? So instead of cout, you're saying out file. Next up, you're going to take in more input from the user, enter your age, and you're going to put it in that same character array data. Um, and then again, you write inputted data into the cout. Okay, so you do in file um, data. Okay, and then write the data at the screen. So you output the data to the screen. And then you again read the data from the file. Okay, in file data, and then you output it uh, to the screen. And finally, what you want to do is you want to close the file. And then file.out file data. So you're going to have data in it. And then finally, you want to close the file. That was writing to a file. The next step is reading from a file. So you open the file if stream for reading a file.data. Reading from a file and then in file data. So what you do is when you do in file.data in this character array, you've got the contents of the file. You want to output the contents of the file to the screen. And then you want to read it again from the file and then output it again. I had a mistake in that example, so let me kind of back up here for a second. When you've taken in the age and then you write the inputted data into the file, then you close the file. After that, you open the file for reading, and then you read the contents into data, and then you output into the output stream, and then you read again from the file. So typically, the two things that you've asked from the user, which is the name and the age, you'll read it, output it. Those two are the things that's kind of in play for this example. So let me go ahead and run it. Z, okay, age 12, I just made that up. Reading from the file Z12, and then what happens is you have this a file.data. So it did write Z and 12 that I inputted from the user. Okay, play around with this example, see how you like it. So that's probably the last lecture. Um, I'll try to see if I can make another one early next week, but if not, then it's probably the last one, and good luck with your final. Thank you.